So, stats, when we talk about stats, right, we are talking about collecting data, analyzing data, right? You talk about like, you do surveys, you do polls, right? And now you've got all this data. So what do you do with it? How do you analyze it? How do you make it meaningful? That's what statistics is all about. All right. So there are a couple of things we can do here. One is, one thing we talk about is measure of central tendency. What that is you talk about what the middle or the center of the data looks like. So for example, if I give you guys a test and then I grade your tests and I have all the scores, now I say, okay, what was the mean? What was the average? What was the median? What was like the very middle score, right? So we talk about like those numbers like in the middle of it, okay? All right, let's talk about some terms here. Population is the entire like everybody in the world that pertains to what you're doing. Okay, so for example, if I have a test, then everybody in the class is the population. A sample is a subset of the population. Okay, so another example, if they do like political polls, right, and do they call every single person in the United States? No. Every single person in the United States, that would be the population. What they do is they ask a sample of people. So they, like they pick, let's say, 5,000 people. They pick 1 million people, and then they use that to represent the population. So that's a sample. Okay, what's an outlier? An outlier, yeah.
Oh, sorry, I was going to answer.
Yeah.
It's like numbers that don't follow the general
trend, right?
The numbers,
so it's a value that's either extremely too high or extremely too low. So if I give you guys a test and let's say, all the scores are, from like 75 to 100, and then one person got a 23, that's an outlier, okay? All right. Let's talk about notation. Okay, what is this? What symbol is that?
Is the denotation.
Sideways M.
Okay, so it denotes the sum of something, right? So it means sum. So that is a Greek letter. That's the Greek letter sigma. That's the capital letter sigma. So in the Greek alphabet, right? The letter in the Greek alphabet that has the s sound, like S in English, that's what it is. Okay, so in English, we have capital S and lowercase s. Those are what gives you the s sound. In Greek, that letter is sigma. Okay, so that's just like if you go down the alphabet, it's alpha, beta, gamma, delta, and so on. And then down the line, you have theta, rho, and then sigma. I do know all of them, but not in order. I don't know them in order, but I do recognize all of them. So that's capital sigma. Whoops. Okay. X is the variable used to represent individual data values. So if you have like 50 test scores, each one of them is x1, x2, x3, x4. N is the number of values in the sample. So if the polling people called 5,000 people, N is 5,000. Capital N is the entire population, so however many million are in the United States, all right? Okay, let's talk about mean. Mean or arithmetic mean, in your words, it's just average. So when you say what was the average score, it's the mathematical word for it is mean. So it's the measure of center, and you add all the values and divide by the total number of values. Okay? Most people call it the average. Okay, here's how math people write mean. It's the symbol for mean or average is X with a bar on top, and guess what it's called? X bar. Okay, so when I say find X bar, that's what it is. All right? It's like J had, but this is less creative. It's just X bar. Okay? And X bar is just the average. Okay, so look at this notation here. This is telling you sum up add up all of the different values and then divide by how many they are. Okay, so sum all of the different values and then divide by the total number. It's just average. So that's for a sample, and then if you wanted to do it for the entire population, you sum it up and then you divide by the population. Okay? So look, math people, they get even more like intricate. If you're talking about the mean of a sample, it's X bar. If you're talking about the mean of a population, look, another Greek letter pops up. What Greek letter is that? That's the letter that makes the M sound. You see it in chemistry. That's the mu. Does anybody take chemistry this year?
Yeah, but we haven't done it.
You haven't done it yet? Anybody take physics? No? Okay. I was also in physics. That's the coefficient of friction in physics. Okay, but that's the Greek letter M. Okay. So here we go. Find the mean of the following sets of numbers. Mean means average. So what are you going to do? You're going to add and divide by how many they are. So how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. The mean, that's X bar. And that's the sum of all of them over 8. All right, so go ahead and plug that in. Let me know how much it is. It's 83, the whole thing, over 8. And Jolie, what did you get? 10.4. 10.4. And that's fine. Don't round to the nearest whole number. 10.4 it is, okay? 1 decimal place is usually good enough. Okay, why do we like using the mean? Like if I have a, series of, like if I have a sample of test scores, why do I like the mean? Because it's reliable. And it takes every data value into account. All right? You know what? There are not. There was one here. Okay, this is actually clean. Nobody used it. Somebody brought it from the bathroom this morning and it's completely clean. Okay. Okay. The disadvantage, the bad part about mean or average is that it's sensitive to every data value. So one outlier can drastically affect the mean, right? So for example, if everybody, scores in like the 90s, and then if one person got a 60, that brings the average way down, even though it was just one person. So that's the disadvantage of a mean, that each score affects it. Okay, let's talk about what a median is. The median is literally the middle value of the data values. But the thing is, they have to be sorted in order of increasing or decreasing magnitude. Okay? The symbol for median is X tilde, like there's a little squiggle on top. Yes? Right now, today, this is just day 1 of this chapter. I haven't given you the whole thing. Okay? So to find the median, you have to sort the values, okay, arrange them in order, and then you have to pick the middle one. So if you have an odd number, then it's the one right in the middle. If you have an even number, then you have to take the average. All right, so let's do this one. Go ahead and sort this one from smallest to biggest. Go ahead and sort this one, please. Number 2. 9. Okay, just sort it from smallest to biggest. So if there are repeating numbers, you have to write them twice. All right, so here we have 1, 2, 3, 4, 5, 6, 7, 8 of them, right? You have an even number. So look, if you split this down the middle, 1, 2, 3, 4, if you split it down the middle, there is not one single middle number. So what you have to do is you have to take both of these and average them. And you get 8. So 8 is your median. All right? All right, so go ahead and find the other one. Find the median of the next set, please. So in this case, you had an odd number of numbers. So the median is just that middle number. So for example, if these were test scores, what does this mean? This means half the population, right, their scores is under 25, and half the population, their scores are over 25. All right? So it's very important. Like if I look at your test scores, oh, what's the median? Okay, yeah, there was a low average, but you know what? Half the students got above an 87, so that's okay. All right? Okay, let's talk about mode. Mode is the value that occurs most often, okay? So it's the value that occurs most often. All right. A data can have one mode, more than one mode, and so on. If there are two modes, we call it bimodal. If it has more, we call it multimodal, or it could just not have a mode. All right, so take a look at this. Find the mode of each of the following sets of data. So look at this. Are any of the values repeating? You have, how many times does this happen? 1.10 occurs twice. Everything occurs once. So the mode is 1.10. Okay. What about for the next one? What would be the mode? What's the number that you see most often? 27 and 55. So those are the modes. It's bimodal and it's 27 and 55. And then in the next one, there is none. Okay? Okay, range. Range is the difference between the highest number and the lowest number. That's all. Okay? Maximum value minus minimum value. Range is the one that we use least often because it really doesn't take into account any of the scores in the middle. Okay, so here are some test scores. Find the range. So what's the highest number here? 92, 97, and then minus 70, 27. That's all. Okay. Standard deviation. This is an important one. And this is one that's used everywhere. It's used in science labs. And it's used in like any time that you have to find, let's say, like percentage of error and stuff like that. Okay. So standard deviation has another symbol. This is the symbol for standard deviation. Okay. Remember how I told you you have capital S and lowercase s in English? And then in Greek, it's capital sigma. And then this is the lowercase sigma. Okay? So they both make the S sound, the S sound. Omega is, this is capital omega, and this is lowercase omega. That makes like the wah sound. Okay, so lowercase sigma is standard deviation. All right, what does standard deviation mean? Suppose you have, again, like suppose I find the average of your test scores, right? If I were to pick a basic test score, right, how far away it is from the average, that's standard deviation, okay? So standard deviation is a measure of how close values are to the mean. Okay, let's talk about how we find standard deviation. So this is the formula for it. And you have to know how to find it. We're going to go through like a whole page of steps. to find standard deviation. All right. Okay, I'll go back to this for a minute. Let's talk about how we find it. Okay. Okay, so here's the formula for standard deviation. And here are the values that we want to find standard deviation for. Okay, so look at this one. It's a sum of x minus x bar. What was x bar? Average squared over n minus 1. So you need to find this x bar, this average, right? So let's first find x bar. Here, x bar is going to be 2 plus 8 plus 10 plus 12 plus 14 over what? N is 5. So 5. All right? And how much is that? I need you guys to be, how much? 9.2. Okay. Now, subtract the mean from each individual value. So what you have to do now is you have to take each number and do that number minus 9.2. So 2 minus 9.2, 8 minus 9.2, 10 minus 9.2, and so on. All right, so go ahead and start crunching those numbers for me. So what's the first one? Right. Negative 1.2, and then 0.8, and then we have 12 minus 9.2. Right. Okay, so that, what we just found is this thing in here. Okay? Now, what do you have to do to that stuff in there? It says take the sum of that stuff. So now we have to take the sum of that stuff. Oh, sorry. Sorry, I missed a step. So here it's the sum of what? It's x minus x bar squared. So now you have to square all of those numbers separately. Okay? So you have to do negative 7.2 squared, negative 1.2 squared, 0.8 squared, and so on. So 7.2 squared. And the next one? Okay. And then 0.8 squared is 0.64. 2.8 squared. And 23.04. All right. Now I have to add them all up. I have to take the sum of all of those. So let's take the sum of all of those. Oh. 84.8. Okay, so now let's go back to the formula. Here's where we are. We found x minus x bar, we squared it, we added all the sum. Now I have to divide by n minus 1. So I take 84.8 and I divide by 5 minus 1, which is 4. 21.2. And then finally, you have to take a square root of all of that to get 4.6. Okay, so that's the standard deviation. That means, what was the average of these values? The average was 9.2, okay? And if the standard deviation is 4.6, it means an average sample here is going to be 4.6 units away from the average. Okay? So suppose I had your test scores, okay? And suppose the average for your test scores was, I don't know, 87, okay? And the standard deviation was 4. That means most people scored 4 numbers away from 87. What's 4 numbers away from 87? 91 or 83. So that means most people's scores were between 91 and 83. Okay? All right. So you're on your own now to do this next one. On your mark, get set, go.
Oh, what?
Okay, so the way I do it is, look, I have to do now x minus x bar, right? I got 6 for x bar. Is that what you guys got? Yes?
Yeah.
So look at what I do. Let me show you the quick way of doing it. I have to do x minus x bar, and then I have to square it, right? So look at this one. To minimize the work, all right? When you square something, the negative goes away. Is that right? So look at what I do. Look at 5, the first point. How many numbers away is it from 6? Okay, I have to do this minus that, right? So 5 is 1 unit away from 6, right? 1 number away from 6. It doesn't matter if it's plus 1 or minus 1 because I'm going to square it. So I just do 1 squared equals 1. The next one, 9 is 3 away from 6. So I do 3 squared equals 9. 6 is,
Easier way of doing step 3.
yeah. This, huh?
This is the easy way to do
This is basically, I'm doing steps 2 and 3 together in one step.
Got it.
Yeah, okay? So then 3 is 3 away, so that's 9. 7 is 1 away, so that's 1. All right?
1 squared is 0. Anything to the power of 0 is 1.
Yes, correct. So now, so this was steps 2 and 3. Next, I need to do step 4, and step 4 is to just add these. 1 plus 9 plus 9 plus 1 is how much? 20. That's step 4. Right. Step 5 is 20 over 4, which is 5. And then I have to take a square root. So sigma is the square root of 5, which is how much these days? Right, 2.2.
I like just doing it the long way.
Well, you're in luck because you get to do B the long way. Okay? So go ahead and do the next one. Sigma is, roughly 3. Okay? All right, let me show you how to do it with your calculator. I have the steps here. Go ahead, take out your calculator, and in the home screen here, what you're going to do is you're going to select this green spreadsheet. Guys, everybody look up here for a minute because I don't want to... Where's your calculator? Okay, so open up the spreadsheet. Okay, in here, let's do the one with the numbers that we were just working, right? So in that first column, what I want you to do is put in the values, right? So that's going to be 2.3.
Wait, do we switch columns?
In column A. So look, 2.3, enter.
Okay, got it.
4.7, enter 1.6, 7.2, 9.4, and 5.1. Okay? Once you're done entering, don't exit out of this. In here, this is, the TI Inspire really makes these like a lot easier. In here, press menu, okay? And you're gonna go to for statistics, and then you're gonna go to stat calculations. I have it all in the handout there. And then you're gonna choose one variable statistics, okay? Here, just number of lists, you only have one list, right? So just press OK. Okay, this is, let me show you what this means. It says, where is your list? It's in column A, right? Is that where my list is? Press yes, unless you put your column like somewhere else. And then here it asks you, where do you want the results to be printed? We want it, just leave it in column B, who cares? Here we go. Here is all this stuff now that it generated, right? Column A is what we had, and then it generated all this stuff. You go down here, sigma, right here, sigma x, that's your sigma. So we got about like 2.9-ish, right? Because all of these, there was a whole lot of rounding going on, okay, while we were doing it. So the calculator obviously doesn't round, and it gives you that sigma like that. Okay? Now, as I mentioned before, you have to know how to use your calculator for this, and you have to know how to do it like manually. So by manually, I mean, I'll say it again. I'll allow you to use a scientific calculator, not a graphing one, those little ones, okay, to do the calculations. But then I also want you to be able to use your calculator for this. So like I might give you a list that's, let's say, 30 numbers long, okay? You're not going to do that by hand. That's how I know that you know how to use the calculator, okay? Yeah.
Can you put on like if it's an assignment or